Good morning, children. Last class we learned the definition of algorithm and few examples of algorithm, even the function of algorithm. Today in this class we are going to learn about flowchart. It's a flowing chart or an algorithm used to solve a particular problem. A flowchart is a pictorial representation of the steps or an algorithm used to solve a particular problem. So what do you have written in algorithm in sentence? Here in the flowchart we are giving in a pictorial representative way. A process of drawing a flowchart for an algorithm is known as flowcharting. The process, the procedure is called flowchart. It graphically represents. What is that? Graphically. Graphics, you know. You are watching animated movies, cartoons. Is it? Okay, so these are graphics. Same way, the flowchart graphically represent the logic. It explains the logic, but same thing. Graphically explain. Represent the logic needed to solve a programming problem. Just a picture is worth 1,000 words. Is it? Simple example. If you watch a picture of COVID-19, like simple ball, no? A ball with the hairs and all. Yeah. If you see the red color, that COVID-19 image, there are not only 1,000, crores of words to speak. Is it? Because of small virus, the whole world is affected, including you too. You cannot go to school. You cannot go to play in the school. You are missing your friends. And everything should be packed. If you go outside, no talk, no smile, nothing, because you are wearing the mask. So with that image talks crores of words. Same way here in the logic also, just a picture is worth 1,000 words. Similarly, a flowchart provides a much better way of solving a problem than writing a lot of descriptive text. For example, if you got two textbooks, which among one is having only text like these sentences, one paragraph after another paragraph, nothing, 10 pages full of text, okay, words, sentences. Same way in the another book you got with plenty of colorful pictures. Which one will you select? Of course the picture one, because that is so attractive. And here also same story, in the picture way also same story explain, which we can understand easily. Picture one, correct. That's why we are all interested in watching cartoons, correct, no? Yes, that is the same thing. Similarly, flowcharts provides a much better way of solving a problem than writing a lot of descriptive text like essays. Is it? The same, the algorithm which you are written in text, we are changing or converting to flowchart because it is easy to understand. I will explain this flowchart. Before that, I am going to explain the symbols and their functions in the flowcharts. Different symbols and their functions. We will see what are the symbols and its name and its purposes. Start, stop box. So if you want to start a flowchart, we use this shape. And if we stop also, same shape. Starting and stopping, we use the same. It is used in the beginning and the ending of the flowchart. Okay, this is the first and last symbol. Input and output box. So giving something input. Example, you are giving A is equal to 10, B is equal to 20. So you are giving input, and you are asking, okay, so what is the result? We have to add both. So A is equal to 10, B is equal to 20. So what is the answer? So output also will come in this the same box, input output box. That is 30. You will get in the same box. Okay, so it is used for accepting inputs or giving output the program. Next one is processing box. Processing. So we have given A is equal to 10, B is equal to 20. Now what is the process it should happen? That is X is equal to A plus B, or C is equal to A plus B, or cost is equal to price into number of products. So like that procedure, the multiplication, addition, subtraction, all exponent, all the process is done in this box. Okay, it is used for writing the processing instructions and doing calculations. Next one is decision and condition box. Example, if we compare two numbers, A is equal to A is equal to B, that means that 10 is equal to 20. No, then A is greater than B. So if two options, the decisions or the conditions comes, we use this decision box. It is used for checking or applying any condition in the program. When the condition will come, if there is an option. Next one, flow line shows the direction. If you go to right side, use this one. Left side, up, down. It shows the direction. There are two types of connectors. This is on page connector, this is off page connectors. Example, if you are writing a program, okay, and in the notebook you are writing like this, okay, this page is over, but still the flowchart is continuing. So what you will do, you will make a one line here, okay, and separate the page, and you will continue to write here. So this is called on page because it is in the same page. On page connector is used to join parts of the flowchart contained within a same page. Which one? Yes, this is on page connector. Whereas the second one, that are used to connect the one part of the flowchart to another. So this one already we have seen. What is this one? Yeah, say please. On page connector. So what about then this one? It is off page. Off page connector for what? Suppose you are writing here in this page, right. This page is over, and you to next page. So in the last you draw like this, and the next page also. So for connecting, we use this symbols. We are briefing the symbols. The first one is start or stop box. Next one is input. This is the input, this is the output. We use the same symbol for input and output. And next one is processing box. Where is the processing box? It is not here. Okay, in this flowchart there is no processing. Decision, this is decision. One decision is second decision has taken. Yes or no. And arrows, there's so many arrows here. Arrows, here arrows, left, right, and all. And connectors are not there. So these are the symbols mainly we use in the flowchart. Now we are going to see algorithm and flowchart in a single problem solving. Algorithm and flowchart. We will see what are the steps included in algorithm and what are the symbols and the way used in flowchart. Step 1. Input two numbers and store them in A and B. Input. So first start, then we are giving this is the input box or output box. read or input A and B. Okay, so and store them. That means we will see A is equal to 10. Suppose A is equal to 10 and B is equal to 20. B is equal to 20. Then we are assigning the value for this variable A and variable B. Step 2. Check whether A is equal to B. See here, is A is equal to B. A, what is the value of A? 10. What is the value of B? 20. Is it equal? Decision, yes or no. Then decision comes. If true, suppose A is equal to 10, B is equal to 10 means then yes, both numbers are equal. Step 3. Print both numbers are equal. See, this is another step. Here, this is the output box. This is the input box, this is output. That means if it is yes, you give both numbers are equal. If A is equal to 10, B is equal to 10. And you stop it. If A is greater than B, go to step 5, else go to step 6. A is equal to 10, we have given B is equal to 20. Then is it same? No. Then you come here. The next one, if A is greater than B, yes, then go print out A is greater. But we have given variable A is equal to 10, B is equal to 20. So answer is no. If it is no, in our program it is wrong. Then, yeah, A is greater and stop. Here you see, no, B is greater and stop. I am briefing algorithm and flowchart. First one, start, input two numbers A and B. A is 10, B is 20. Now, is A is equal to B? A is equal to B? No. If it is yes, you print out and go to stop. If it is no, again option, is A is greater than B? 10 is greater than 20? If it is yes, print this one and stop. If it is no, B is greater. And what is the answer now? Yes, stop it. So like that, we can write algorithm and flowchart very easily. I know you are a little confused. Next class, we will continue to write algorithm and flowchart together. So it will be easy for you. Thank you.